Hello and welcome to the MyVue prototype wearable camera for the Dare to Dream Different contest. My name is Jim Wilson and I'm just going to give you a brief intro to what the prototype is about. It's more than just a wearable camera in that it's meant to be a prototype of a device that augments the senses. As the person wanders around the room, the camera is capable of identifying content that's important for videotape or for capturing and later viewing through the SD card. And in this way, it's the person wearing the camera doesn't have to rely on their own senses, and the camera acts as an extension of their senses. And this can be used in various scenarios in a security environment to allow the person to capture information about the scene without necessarily knowing all the things that are around them. It also provides audio feedback, so if the device detects an event, that person can get information about where the event is located, rotate their head to that position and get more video. It's also useful in an environment for perhaps somebody that wants to be in a tourist environment but doesn't want to stop and take a picture of something, and it just becomes an extension of their normal activity. So let's get started and let me give you an overview. Okay, what you're looking at in this assembly of parts is the prototype of the MyVue wearable camera. The left side here is the sensor head itself, and that's attached temporarily to a hat. Remember, this is a prototype. The left part is the sensor module. The sensor module contains a sound sensor at the bottom, ultrasonic and light sensor, and the thermopile array. That provides a collection of sensor information which is statistically analyzed according to preferences that the end users provided on the Tahoe 2 board. And that determines the position of the sensor module, which rotates with the servo on beneath. And that orientation, that sensor module, determines the corresponding orientation of the camera. While the camera is recording a video sequence, the sensor module continues to pan the field of view looking for objects of interest for the next object of interest. So you can see the red wires in the background. That's attached to the I2C bus. That's where all the sensor information is provided. There's a small pancake speaker on the bottom. That goes to a speech synthesizer. The speech synthesizer provides more information about what's happening in the field of view, and that gives the user, the wearer of the MyVue camera, a chance to rotate their head, much in the same way that the sensor module does, to look at that object of interest and get more information about it directly. So you can see the serial cable going to the camera module, the I2C sensor cables, red wires going to the I2C interface, and that provides sensor that allows the Tahoe 2 board to collect sensor data, and the I2C bus is the primary interface to all the sensors. So the Tahoe 2 board and the .NET Compact Micro framework, provides feedback, provides control for the end user, provides statistical analysis of all the sensor data coming in over the I2C bus, and also controls the camera as well. What you're looking at is the sensor head, and you're looking at the sensor module pan left and right, collecting information from all of the sensors, sending it to the Tahoe 2 board where it's statistically analyzed. The module on the right is the camera, and as I approach the sensor module, the camera module changes position to point to my position as I approach the sensors and come into the field of view, into range. Okay, once MyVue has collected the images and stored them on an SD card, then the SD cards move to a PC, and in desktop application combines the images into an AVI file that's been annotated with the events that describe why the sensor module actually captured that image or that image sequence. So here you see just an example of some of the images in the downstairs when we were wandering around downstairs in the demo that were captured based on the sensor information from the sensor module. The great thing about the micro framework is I was able to get going with it almost immediately. I was able to upload an application, I was able to independently start the platform, disconnect it from the debug environment, and then just have that application run. And easily create a user interface. And that's something in a normal embedded environment I'd have to build the OS image, I would have to learn more about the build environment. I'd have to learn more about, I'd have to configure the target platform for deploying it. And then debugging was very simple. It's just a matter of making a USB connection and then single stepping through the code, and it just made the connection with the debug environment. And that hasn't always been the case, even with other Windows embedded products especially. That was the great thing. But the thing I really missed was when I was writing some of the I2C drivers in particular, or any driver even for a device connected to the serial port. Probably less so with the serial port. But there were times where I felt like it'd be great to have access to the native code because I'd get an exception's getting generated and there's just not enough information in the exception. It could be some bit of information about the way the register was configured or an I2C device that wasn't there at that address. And it isn't enough just to keep adding more and more detailed exception messages. I think I want to know that I can always look at that native code to see how it's functioning and to know that I can modify the existing native code to work better with a device, and that I'm not handicapped in that way. And then there were times where I knew I wanted to access the SD card on the Tahoe 2 board, but there were some issues with doing that, and I was reading the forum, and I was hearing about some problems that were being fixed, and eventually the new version would come out. But I felt handicapped by not being able to control the hardware, which as an embedded systems engineer I've always been able to do, and now I'm relying on somebody else to do that for me. Even though I can do it more easily, I just know that at some point, if I want to make a truly successful embedded device, I'm going to have to extend its capabilities beyond what's provided by the OEM of that particular platform. And just having the comfort of knowing that I have access to the native code to do that would be great. But it was the simplest embedded environment in terms of getting functional that I've ever worked with before. But when I wanted to dive deep, I had issues. So, in summary. Well, the thing to remember about MyVue is that it's a prototype. It's not as wearable as wearable cameras need to be. But eventually, we can envision a case where there might be something like a Bluetooth earpiece that contains the camera in a single unit and then has an interface that's extended by the PC that provides for configuration through the Bluetooth for sensory augmentation. It's not just about collecting interesting images that you would otherwise wouldn't have time to while you're walking around and you have to pull out the camera and that's too inconvenient. It's about collecting extra information about your environment, hearing the audible feedback and knowing that you've got video coverage. You could imagine the person as kind of a walking security camera and potentially having eyes behind their head, having the ability to see parts of their environment beyond the limitations of their own senses. So MyVue is really more about a first step in the world of digital IP, digital video, in the realm of sensory augmentation. Sensory augmentation, I believe, at some point will be a whole new product category. Well, that's it for the MyVue demo, and that gives you an overview of what things are like, what things might be like in the future for MyVue, and for sensory augmentation and wearable cameras in general. Thank you.